Is your van a secret mobile power plant? The pursuit of true off-grid independence in a camper van often confronts a fundamental challenge: consistent, reliable power. Owners face a technical dilemma between convenience and the inherent limitations of mobile energy systems. Failing to address this often results in dead batteries, compromised travel plans, and unexpected costs, transforming liberation into a liability. A van's electrical system, at its core, involves four critical components: power sources, energy storage, power control, and power distribution. Each must be meticulously selected and integrated to function as a cohesive, self-sustaining unit. The initial step in designing a robust off-grid system involves a comprehensive power audit. This process quantifies the daily energy consumption of all devices, from LED lighting to refrigeration and charging electronics. Each appliance's wattage and anticipated daily runtime are calculated to determine total daily watt-hours or amp-hours. For instance, a 60-watt refrigerator running 10 hours daily consumes approximately 600 watt-hours. On a 12-volt system, this translates to about 50 amp-hours. Once daily consumption is established, the next critical component is energy storage, the battery bank. Lithium iron phosphate, or LiFePO4, batteries have become the industry standard for off-grid vans due to their superior cycle life, deeper discharge tolerance, and lighter weight compared to traditional lead-acid batteries. LiFePO4 batteries can safely be discharged to 80 to 90% of their capacity, offering 3,000 to 6,000 plus charge cycles, significantly surpassing the 300 to 500 cycles of lead-acid alternatives. However, simply installing LiFePO4 batteries is insufficient. Correct sizing is paramount. If daily usage is 1,200 watt-hours on a 12-volt system with 80% usable capacity, approximately 125 amp-hours of usable capacity are required. For practical application, this often means a total battery bank of 250 to 300 amp-hours to provide a buffer for low solar input days. Power generation primarily relies on solar panels. These convert sunlight into DC power, which then charges the battery bank via a charge controller. Solar panel efficiency is influenced by factors like weather, panel angle, shading, and temperature, with geographic location significantly impacting daily production. For example, a 300-watt solar setup might yield 1,200 to 1,800 watt-hours per day under good conditions, though real-world output can be 20 to 30% lower. The charge controller is a vital intermediary, regulating voltage and current from the solar panels to prevent battery overcharging. Two primary types exist: pulse width modulation, or PWM, and maximum power point tracking, or MPPT. PWM controllers are simpler and more cost-effective for smaller systems, but operate at a lower efficiency of 70 to 80% as they must pull panel voltage down to battery voltage. In contrast, MPPT controllers are more sophisticated, achieving 95 to 99% efficiency by continuously tracking the solar panel's maximum power point, making them ideal for larger arrays and higher voltage panels. Another critical power source is the vehicle's alternator. While the alternator's primary function is to power the vehicle's systems and starter battery, it can also charge auxiliary batteries while driving. However, directly connecting a large lithium bank to a factory alternator risks overheating the alternator and vehicle wiring due to the high current draw of deeply discharged LiFePO4 batteries. To mitigate this, a DC-DC charger is essential. This device limits current, protects the starter battery and vehicle electronics, and provides the correct charging profile for lithium batteries. For systems with extensive power demands, a dedicated secondary alternator paired with a smart alternator regulator offers significantly higher output, sometimes exceeding 8,000 watts at high idle, providing rapid charging for large battery banks. For powering standard household appliances, an inverter is necessary to convert the 12-volt DC battery power into 120-volt AC power. Pure sine wave inverters produce a smooth, consistent waveform identical to grid power, making them suitable for sensitive electronics, medical devices, and appliances with motors. They also boast higher efficiency, often exceeding 90%. Conversely, modified sine wave inverters produce a stepped or blocky waveform. While more affordable, they are less efficient, typically 70 to 80%, and can cause issues with sensitive electronics, leading to buzzing, overheating, or reduced lifespan for certain appliances. The choice depends on the specific loads. For complex electronics or motors, a pure sine wave inverter is the appropriate technical choice. Beyond component selection, system safety and proper wiring are non-negotiable. Electrical faults are a significant cause of vehicle fires and converted vans. Key safety practices include sizing every wire for both current and length to prevent voltage drop and overheating. Each positive conductor must be protected at its source with a correctly rated fuse or circuit breaker installed close to the battery. Utilizing marine or RV-grade stranded copper wire, rather than solid-core residential wire, is critical for mobile applications due to constant vibrations and movement. Proper crimp connections with heat shrink tubing prevent loose, high-resistance connections that can overheat. Additionally, establishing a dedicated negative bus and bonding to the chassis at a single, well-prepared point helps maintain system integrity. Regular maintenance is vital for system longevity and performance. This includes monthly visual checks for discoloration, loose connections, or corrosion. Battery voltages and charging functions should be verified, and fuses/breakers inspected. Keeping wiring diagrams and service records up to date is crucial for troubleshooting and ensuring ongoing safety. Ultimately, transforming a van into a mobile power plant requires meticulous planning, precise component selection, and adherence to stringent safety protocols. If you are considering building or upgrading your off-grid electrical system, thoroughly research and plan each stage, or consult with professionals to ensure reliability and safety.